Welcome to MvDad.com for simple, stable, structured solutions. Just log in. In this session, we will see column design. Just click on the column, then submenu will appear. Select the calculations. Working loads from the beam on column number C5 at floor number 1. From B3, B4, B9, B10, load is transferred to the column number C5. We have divided that load in two parts, dead load and live load. Same way, end moments, dead load and live load. Beam span, beam width, beam depth. We are calculating working bending moments as per fixed end method from beam number B3, B4, B9 and B10 on column number C5. These bending moments we have calculated and displayed here. Same way for stiffness from beam that we have calculated. In working column moments after 3D that we have calculated. Now working load on column as per the tributary area method. From 4th floor, 3rd floor, 2nd floor, the loads are there. We have shown displayed, and accordingly that total load is calculated as per the tributary area method, that is applicable to live load 1, 0.9, 0.8, 0.7 and 1 as per the IS code. This comes the value as per the traditional load from the columns from the top floors. It comes around 1476, whereas as per the tributary method it comes around 1407, roughly 70 kilonewtons less. We have tried our level best to make the section economical. At the time of modeling, we only selected the location, and rest all the dimensions we are calculating as per the load conditions. In this we will see we have assumed section 300 by 500. If it is safe, then we will proceed. Otherwise, we will revise the section till the section is safe. We assumed 300 by 500. We assumed the percentage of steel is 0.7, and according to the load area required that we have checked, D assumed is 500 mm, which is more than the D required as per the IS code. So we have proceeding further for longitudinal reinforcement of the column. We are preferably it should not be more than 4%, but at this stage we are assuming 0.7% to calculate the economical section. If it fails, then we will revise the percentage of steel. Main tensile steel as per the load conditions, we have seen that we require 16 6 number of wires, 16 mm dia. AAC provided 1206. But when we check it with the carrying capacity of the section, the carrying capacity of the section is 1464, whereas the load is 1476. Hence section is not safe for axial load. So we are revising the section. Instead of 500, we have raised the depth to 530. Now according to the 530, we will recheck percentage of steel, main tensile steel. In this case, we got the 6 number of bars, 16 mm dia, and 2 number of bars, 12 mm dia. That means number of steel and section sizes increase. Now, if we compare the PU carrying capacity of the section, now it is less than the PU is 1476, which is less than the PU carry capacity of the section 1592, and section is safe. Now further we will design the lateral ties. It should be less than 4 dia, main steel dia divided by 4. It comes around 4 mm. We are considering 6 mm minimum dia, but as per 13920 clause 7.1, the lateral ties should not be less than 8 mm. So maximum of above 3 we are considering, hence it is 8 mm dia for the lateral steel. Accordingly, that percentage of steel provided lateral ties 8 mm dia, 260 mm center to center, and it should not be more than 150 mm. Now check for the least lateral dimension. As per IS 13920, it should be 20 dia. Here it is 320. The maximum of 3 above 320. Therefore, due to the centering facility, it's provided 380. We have assumed 300 mm, but due to 13920, we have changed the section to 380 mm. That means 380 mm by 530 mm. Check for cover, unsupported length, effective length, ideal axial strength, axially loaded column. That calculations, it's detailed, one can go through it and can understand. Axially loaded column, clause 39.3. MU interaction chart, 3 cases are there. Case 1, PU MU case 1, where MU x1, PU MU case 2, when neutral axis lies outside the section, PU M case 3, where neutral axis lies inside the section. Accordingly, to further proceeded, we have calculated the story-wise stiffness and y direction and x direction, which we require for the earthquake analysis. Same way, beam story-wise stiffness and y-axis and x-axis. Calculation of common column movements, moment as per the 3D analysis, slenderness detailing, if the column is short or slender, accordingly that is designed. Now check for the PUTM 1407 and moment MUY1 31.17 and 28.14 in x direction and y direction respectively. That we had checked, it comes less than or equal to 1, hence safe. Then quantity, section size, which we had raised from 300 to 500, now it is 380 to 530. Quantity is there. Steel weight, we have calculated 6 number of bars, 16 mm dia, 2 numbers of bars, 12 mm dia. Similarly, stirrups that we have calculated, total steel required for main steel is 33.72, For secondary it is 5.07 kg. Total steel 38.79 for the column number 5, floor number 1. We have in this table, as per the 13920, we have compared all these classes 7.1 to 7.4.6, and we have found the section is safe as per the IS 13920. The final column steel design is column height 2240, effective cover 56 mm, M20 Fe415 steel grade, sectional size B380, depth 530, effective length 2240, quantity is 0.451 cubic meter. Main steel 6 number of bars, 16 mm dia, plus 2 number of bars, 12 mm dia. And same way, the stirrups 13 number of bars, 8 mm dia. This is the full calculation. One can go through it for each and every column, can satisfy himself. If there is any mistake, wrong, correction, please let us know. We will update and make the corrections. Now we will see the sectional design which we calculated. Section size is 380 mm by 530 mm. Number of bars 3, 16 mm at top, at bottom 16 mm, 3 bars, at the center 2 dia 12 mm. For the full floor, steel schedule, steel design schedule, one can go through it for each and every floor. C5, floor 1, which we have seen the full detail design, 380, 530, 2240, 6 number of bars, 16 mm dia, 2 number of bars, 12 mm dia. Same way, steel stirrup. For each and every floor, one can select the floor and select that steel design, steel schedule, one can get the values. I hope I explained the detailed calculations, and for any section if they want to print, just they can print it. Simple. In this section we have discussed about the column design. Hope we have explained it. Thank you.